Hello, this is all you need to know, trigonometry. So now we are diving deep on everything you need to know about trigonometry before we approach trick questions. Yeah, so I've tried by all means to summarize everything as much as possible. So if you're watching this video, just know you've just gained information for that you would have been taught in class for about 2 weeks or 3 weeks, and I've broke it down to just few minutes. I hope this one will be useful to you, as I hope so. So trigonometry, what is trigonometry all about? So trigonometry is a relationship between the angles and the lengths of the sides for triangles. That is that we'll be working with triangles and angles. So remember, triangles, they have sides, 3 sides for a triangle, and then the relationship between those sides and the angles that have been formed by those sides. Okay, so we start focusing on the right angle triangle. What do you need to know about the right angle triangle? What do you need to know is that the right angle triangle has 3 sides. Okay, all triangles, they have 3 sides. So, but for right angle triangle specifically, it has an hypotenuse side, the longest side, and then it has an opposites and the adjacent side. So opposites and adjacent side will differ because according to hypotenuse side, it will always be the longest side, period. That is that. But for opposites and adjacent will differ in terms of the angle of interest. What am I talking about? Let's talk about this one. You see, this one, angle of interest is B. Okay, angle of interest is angle B, as you can see there. So if angle of interest is B, that means opposite side will be the side that is facing, or it's opposite towards angle B, like this one. Okay, it's facing angle B. So then adjacent will be the remaining side. Let's go for this one now. The angle of interest this time, it's A. You see, it's up there. It's A. Now, which means the opposite side will be which one? Will be this one. Now, this is the opposite side that is facing the angle. And then the adjacent side is this one this time. So it will differ for adjacent, and opposite will differ in terms of the angle of interest. And then remember Pythagoras. If you are given in a right angle triangle, you are given 2 sides. In order for you to calculate the third side, you'll make use of the Pythagoras theorem. And then remember this: whenever you are calculating the hypotenuse side, it will be the hypotenuse side equal to, and then you add the other 2 sides, and then you square, right? Remember, if let's say here AB squared is equal to, and you're calculating the hypotenuse side, which means you will add AC squared plus CP squared. But whenever you're calculating the other side, let's say you're calculating the adjacent or the opposite side, you'll have to subtract. You'll always have to subtract from the hypotenuse side distance. That is that. Then let's move. Let's move. Now, why are you jamming? Okay, and then trigonometry mnemonials. Okay, some they call it abbreviation, but I call it a mnemonial. Mnemonial. English, right? So this mnemonial, it's SOHCAHTOA. It's sine opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over adjacent. This one will help you to work out the trig ratios. As you can see there, whenever you see sine theta according to trig ratios, it is opposite over adjacent. Whenever you see cos, it's adjacent of hypotenuse, as you can see. And then reciprocals, especially for grade 10, you'll be using reciprocals, as you can see here. And then whenever we are trying to calculate, remember, if you want to calculate the third side, let's say you are given already in a right angle triangle, you are given 2 sides, and you want to calculate the third side, you can use Pythagoras. But what if now you are only given an angle and the other side, okay, and then one of the sides? How are you going to use Pythagoras on that one, because you're only given one side? That is when you can make use of the trig ratios. Trig ratios, as long as you are given an angle and a side, but also if you are given 2 sides and you are calculating an angle, you can use the trig ratios. So trig ratios are so helpful. As you can see, here is an example here that you can make use of to practice the trig ratios. And then another thing, Cartesian plane. you have to master your Cartesian plane in order to make use also the trig ratios. Here we'll be working with coordinates, right? Coordinates, remember, x is to y. And then remember, r will always be positive. Okay, r will always be positive. And then remember, sine theta is opposite over over hypotenuse, which means now your y will always be, according to sine theta, your y will always be opposite, and then your r is hypotenuse. And then cos, it's adjacent over hypotenuse. Remember, for adjacent, you will always now have to substitute the value of x. If you are working with the Cartesian plane, if you are working with the Cartesian plane, we'll make use of y, r, and y. That is that. And then for tan, it's opposite over adjacent. Now your opposite is y, and then your adjacent it's an x. Just know about that. And we'll also make use of a Pythagoras theorem. If you're already given the value of x and y, and then you want to calculate the value of r, you're going to make use of the Pythagoras theorem. And then in most cases for the Cartesian plane, these are the questions that you will be asked on, and then you should follow these steps. Firstly, if you are working with a question involving constructing of a triangle or an arm, in a correct quadrant, you'll make use of these steps. Find the correct quadrant by identifying is sine positive, is cos positive, is tan positive, and then according to the interval that is given to you, as you can see there is an interval greater than 90 degrees but less than 270. That is how you're gonna make use of that interval to identify the quadrant. So after that, and then you draw the triangle, and then you fill in the numbers making use of Pythagoras. Okay, and making use of the numbers that are already given. As you can see there, we have sine theta 3 over 5, and that 3 is for y, and then that 5 is for r. Now the remaining variable, it's x, and then you calculate the x making use of Pythagoras, and then at the end you solve the questions. Then we move. Okay, and then this is how we got to identify according to quadrants, as you'd usually be taught that in quadrant 1 all functions are positive, quadrant 2 only sine is positive. How did we get to that? We made use of this table. So whenever you are talking about angles that are greater than 0 but less than 90, that is quadrant 1, as you can see here. Whenever we are talking about angles that are greater than 90 degrees but less than 180, we are talking about quadrant 2. Whenever we are talking about angles that are greater than 270 but less than 360, we are talking about quadrant 4, so on and so forth. And then what is happening in quadrant 4? Check here. R is always positive. In all quadrants, R is positive. X depends which quadrant are you in, and then in terms of y over r, x over r, will end up with a positive or a negative number. That is how you conclude that sine will be positive there, or cos will be positive there, or tan will be positive on that particular quadrant. That is that. And then this is all you need to know again for that part. And then quadrants, again, for your quadrants, you have to know, already specified for quadrant 1, all angles there should be greater than 0 but less than 90 degrees. As you can see, those angles, whenever you are given an angle that is an acute, it will fall under quadrant 1. And then how will that help you? It will help you to easily identify a particular quadrant, so you can be able to make use of a reduction formula. And then for quadrants, they use a cast diagram in order to apply reduction. So in this cast diagram, A, S, T, C, all students take coffee. They usually make use of that mnemonial again. But quadrant 1, it's when we are using a reduction, it's 90 minus, quadrant 2 90 plus, or 180 minus, and then quadrant 3, so on and so forth, as you can see there. Make sure you familiarize yourself with that. Then again, trigonometric identities now. Make sure you know your identities. For number 1 identity, whenever you see sine squared theta plus cos squared theta, that is equivalent to 1. But you can also make use of that to calculate to identify, to make use of an identity. For sine squared, you can just transpose cos from this one, and then you'll have 1 minus cos squared theta. And then whenever you see 1 minus cos squared theta, you can rewrite it as sine squared theta. Or whenever you see sine squared theta, you can rewrite it as 1 minus cos squared theta. It depends. According to identity problem, It depends. Whenever you are changing something, just keep it in your mind. How will it help you? Just think, how will it help you to change it? Why should I change it? How will it benefit me by changing it? So you have to keep that in mind also. And another identities, if you are in metric, it's double angles. For identities for double angles, sine 2a is equal to this, and then cos 2a, a double angle for cos, it has 3 identities. And then we have compound angles for metric. Compound angles, make sure you memorize that, but they are given in your formula sheet, right? And then for tan theta also, whenever you see tan theta, you can write it as sine theta over cos theta, but at some point they will need you to manipulate it in a particular manner. But whenever you see sine, especially for double angles, sine for compound, not double, according to this identity number 2, sine theta can be written as tan theta times cos theta. How did I get to this? You do cross multiplication here on this one. Do cross multiplication and then you'll get to this. And then also whenever you are looking for cos, now what do? You multiply both sides by cos, and then it will be cos theta is equal to cos theta times tan theta is equal to sine theta, and then you divide both sides by tan theta, and then your cos theta is equal to sine theta divided by tan theta, which means if it can help you, whenever you see cos theta, you can equate it to sine theta over tan theta. Maybe you are trying to cancel out something. If it's gonna help you, you can do this accordingly. And then special angles now. What do you need to know about special angles? You can use your calculator, but they would usually say without making use of a calculator. So let me show you something. The only time they're gonna catch up with you that you used your calculator is when you have sine 45, cos 45, tan 35. They're gonna catch up with you. Why? Let's check on it. Sine 45. I'm gonna show you one example. Sine 45, you can see it's giving you root 2 over 2, but let's go and make use of a diagram. Now the angle of interest is 45. For sine 45, sine is opposite over hypotenuse. So for opposite, it's 1, right? And then hypotenuse, it's square root of 2, which means sine 45 is 1 over root 2 according to the diagram without making use of a calculator. Okay, so the answer, without making use of a calculator, is 1 over root 2, but calculator is giving you root 2 over 2, which means whenever you are seeing a root 2 over 2, you can rewrite it as 1 over root 2, just to be safe. And then also for tan 30 is going to give you, because cos 45, I think it's going to give you the same root 2 over 2. And then now let's use tan 30. See, tan 30 is giving you root 3 over 3. Just change this one to 1 over root 3 in order for you to be safe. That is that. Very, very important, that one. And then whenever you are working out a general solution, make sure you follow these steps. Start by checking if can you be able to simplify, can you be able to factorize, and then go for reference angle, and then you choose the quadrants, and then you solve. Make sure you familiarize yourself with this again. And then for trig functions, this is all you need to know about trig functions, man. Make sure you know. Taking it from the mother graphs. These are your mother graphs without any changes. This is your mother graph, and then after that, get to understand the changes. As you can see here, we have A. What does A do into your graph? What does A also in your tan graph, your cos graph, and then your sine graph? What does A do? Okay, what does A brings in terms of changes? And then K, what does K do? What does K do here? And then it's very, very important to familiarize yourself with that. And then let's go and check the effects of A. Here is the effects of A. Your A affects the amplitude. So whenever you change the A, it affects the amplitude, as you can see here. Then let's move. Just be quick. And then also your K, what does your K do? Your K indicates the construction or expansion of the graph. Your K affects the period of the graph. That is that. And then your P shifted the graph horizontally. Your P shift the graph horizontally, and then your Q shifted the graph vertically. Just get to understand that. And then your 2 and 3D dimension problems, what happens there? Just make sure you understand your sine rule. Here is it. Check on it here. And then let's move to your cos rule. Familiarize yourself with that, your cos rule. And then in most cases, not most cases, but sometimes you will be tested on proving the cosine rule. So here is how you prove it. And then after that, you go for your area rule, how to apply your area rule. You'll be given cases. As you can see, you have cases. What if you have to calculate making use of case 2 or case number 1, depending on the question. And then get to understand your angle of elevation. What is the angle of elevation? That's the language for 2D and 3D dimensions questions. If they're talking about the angle of elevation or the angle of depression, what is that? Yeah, as you can see. But let me just show you the angle of depression. The angle of depression, it's facing the, let's say you have something like this. Let's say you have something like this. This is your angle of elevation. And then what if this is your right angle triangle? This is your angle of elevation. And then now what if you have something like this? Now this is your angle of depression. See, now your right angle triangle is facing down, and then this is the normal one. So this is how you do it. So here, as they're asking you about the angle of elevation, that means they're asking you about angle S. Let's say angle S1, because you also have another angle of S this side. That is that. Thank you for watching. This is all you need to know. Trigo.